And we're back with another PicoCTF challenge. This time we're looking at Easy1, which was a cryptography challenge. Description: the one-time PAG can be cryptographically secure, but not when you know the key. Can you solve this? We've given you the encrypted flag, key, and a table to help. Then we're given ciphertext with the key of solve crypto. Can you use this table? We'll download it to solve it. And the hints are, wrap it in PicoCTF once we figure out the answer, and the answer should be in all caps. So we're presented with the table, and we have ciphertext, and we have a key. So the way that you do this is you start on the left, and you're going to take your key, and for example it's solve crypto, so S, and then the first letter is U. So you would move all the way up to the top, and then you would see that this translates, sorry, maybe I didn't make this clear. So S, you go to U, then you find that this maps to C. So everything on the top is your output, everything in the middle is your ciphertext, and then the left is your key. So I had no interest in doing this. This is taking forever. So whenever something is dumb and manual, you might as well try to, sharpen the saw and do a little programming, all that good stuff. So what I did was I took the table, dumped it into this Python script, and the first thing I did was I wanted to do a split. So I wanted to split for new lines. So I did that, and then I got lines. And then for each line, I wanted to split it again. So I know there's a key here that I'm going to use. And then the key has a whole bunch of different ciphertext entries, right? So we are going to do a split on that pipe character, and we'll get key and entries. And then further, we're going to split the entries on the space character. So we want to get each one of these by splitting them on these spaces. So now that we have the keys in the entry, we can create a lookup map where, given a key, we can find in this list where exactly the ciphertext is. And then what we can do is we can look up based off of the index here. So let's say the key, let's use what we had, solve crypto. So the key is S, and we're going to look up, now we have a list that's composed of these elements. We're going to look up the index of U, which is going to be 2. And then if you look at the very top of the table, you'll see this is just in alphabetical order. So index 2 of the uppercase alphabet is C. And so that's what I'm doing here, is I'm going through each of the key elements and the cipher elements. I'm finding the index in my alphabet. And then for all the uppercase characters, I look and I see what is this index in terms of an uppercase character, and I add it to my message and I print my message. So let's go ahead and let's run through this, and I'll show you this in action. So you can see we've split into different lines. Then for each line, we're going to split again. Here we can see that A has these entries, which we'd like as a list. So we did that here. It's called entries. Now we're going to add it to our map. So let's take a look at our lookup map, and we can see that A maps to these guys. Cool. So let's run through, get all those done. And now I'm going to start running through, and based off of my key and my ciphertext, I'm going to start to decode. So my first key element is the S, right there. And the S has a lookup table of STUV, and here we'll check to make sure. S has STUV, perfect. And then the cipher is U, so we need to look up where is U, and the answer is index 2. You can see it right there, which maps to C. So perfect, this is working correctly. Let's go ahead and let it run. At the end, we get a message, crypto is fun. So let's go ahead, we'll submit that, and then I'll talk just a little bit about the cipher that's being used, and I'll show you one other way to do this. It's a little easier. So perfect, it accepted it. So this is called the Vigenere cipher, and it's a series of Caesar ciphers. If you've done the Caesar cipher where it's just shifting things, so like A to C, B to D, would be a shift of 2, for example. It's a series of these, and you have a keyword. So they talk about it here. A keyword that's being repeated. So I would say like maybe my keyword is lemon in this example. Then you would repeat this keyword as many times as necessary, you being the person who received my ciphertext, to cover whatever you were given. And then you would get in those chunks, as you kind of read things out at 5 characters at a time using lemon, you would get the plain text. So when I looked at this, I was like, this doesn't look like a one-time pad, because a one-time pad is just a series of random characters. It's the world's most secure and simplest cryptography, right? But what's interesting is, as I was reading this, where did it say? It becomes a one-time pad, and I can't find it now. Essentially, if you have that key that we were talking about, and it is as long as your message. Here we go. Vigenere cipher with a completely random and non-reusable key will be as long as the message and become a one-time pad. Yeah, so the issue with a one-time pad and with this, though, is if you're sending a key that's as long as your message and you can only use it once, well, you have to get that key to the person out in the field, right? You have a general or someone and you want to give them something important, and you want to run this message out there. If you had a way to submit the key, wouldn't you rather just send the message? So it's a chicken and egg issue. But that's what they're talking about here. And so in the example they had, this would in fact be a one-time pad, because our key is as long as our message and it's only used once. So you can't apply any cryptanalysis based on repeated use of this one-time pad. And one last way to do this that's pretty awesome and would have saved me some time if I'd known was CyberChef, which has a Vigenere cipher decode. So we will pull this guy out here and we'll throw in solve crypto in our ciphertext. It's kind of fun. You can watch it decode right there as I type or remove. So yeah, like, comment, subscribe. Appreciate it. Bye.